Saugus, Massachusetts, 1645. The country's first blast furnace was producing 3 tons of pig iron on a good day. Today, giant blast furnaces can produce up to 10,000 tons of hot metal a day, a far cry from the early 3 tons at Saugus. For modern steel producers like Bethlehem Steel, Saugus was just the beginning of a mighty industry. The blast furnace is one of the first steps in steelmaking. Here, iron ore, limestone, and coke are charged into the top of the furnace. As they descend, they're heated by gases which are released when blasts of preheated air burn the coke in the lower section of the furnace. The heat and gases reduce the ore to molten iron. Despite its size and the massive amounts of raw materials it consumes, the blast furnace is a very precise operation, with state-of-the-art electronic process controls. But as the early iron masters discovered, iron is brittle and unsuitable for many forming applications. The solution? Steel. In the early days, making steel was an art. Today, steelmaking is a highly technical and sophisticated science. Large computer-controlled furnaces, called basic oxygen furnaces, or BOFs, refine iron into steel. Every 45 minutes, the BOF produces a 300-ton heat of steel. The vessel tilts to receive cold steel scrap and molten blast furnace iron. Here, a computer calculates a mathematical model to ensure the correct additions of fluxes and scrap for specific metallurgical properties. With the furnace upright again, large volumes of oxygen are blown into the vessel through a water-cooled lance. The oxygen quickly raises the temperature of the bath to 3,000 degrees Fahrenheit. This rapid oxidation reduces impurities in the molten charge and converts the iron to steel. The steel is tapped into a ladle where many refinements are made while the metal is still molten. Refinements like ladle treatment, where additional alloys are added for precise chemistry, and vacuum degassing for improved formability. The first solid forms of steel are produced in a strand caster. Here, molten steel is poured from a ladle into a reservoir called a tundish in the top of the casting machine. From the tundish, the steel flows into the caster's water-cooled molds. As the molten steel passes through the molds, a thin skin begins to form. Similar to water turning into ice, the emerging steel becomes solid as it descends through a water spray cooling chamber. Casting machines come in many shapes and sizes and produce a variety of semi-finished steel products. Blooms, which are mostly square in cross-section and used for rails, beams, and columns, or slabs, which are used for flat-rolled steel products like sheet, strip, and plate. For flat-rolled products, the slabs are taken from the caster to either the plate mill or the hot strip mill. In the plate mill, slabs are reheated to a temperature of 2,400 degrees Fahrenheit to make them pliable, then rolled into a wide range of lengths, widths, and thicknesses. The plate goes back and forth through a series of mill stands, each containing huge rolls that squeeze the steel until it is reduced to the desired thickness and width. Depending on the final thickness, shears or torches cut the plates to length. Special heat treating and quenching operations fine-tune the plate's mechanical properties. From bridges to rail cars to heavy equipment and pipelines, steel plate can be found across the nation and around the world. Some slabs leave the caster for the hot strip mill, where they are also reheated and reduced in thickness. In the hot strip mill, a series of rolls squeezes the slab into a thin, flat ribbon of steel in a single, continuous pass. The strip is coiled and cooled before it leaves the mill. Like plates, hot-rolled sheets have an impressive list of direct applications, products we see and use every day: automobile frames, machinery, tubing, and other fabricated products. From the hot mill, most steel sheet continues onto the cold strip mill, where it is finished to demanding customer specifications for surface quality and formability. The sheet's surface is cleaned by an acid bath in a process called pickling. From pickling, the coil goes through rolling stands that make it even thinner. This process can reduce the sheet thickness to 1/16 of an inch or less. Once again in coil form, the sheet is now very flat and smooth, but it's too stiff for some applications. So it goes through a heat treating process called annealing to increase formability. After annealing, the sheet is fine-tuned in the temper mill, where it is rolled to impart the final properties for showroom surface and superior formability. Because of the high visibility of many sheet steel applications, like automotive and architectural, special corrosion-resistant galvanized coatings are used. The newest coating lines clean, heat treat, and coat the sheet in a single continuous process. Today's coated steels not only resist the elements, they create a smoother, superior surface that looks great, bare or painted. Steelmaking today is very different from its humble beginnings at Saugus over 300 years ago. We've come a long way in a short period of time. Today, steelmakers believe it's important to do more for their customers than just make steel. Bethlehem Steel is committed to giving customers a quality product, superior service, and much more. We work closely with our customers to develop new and better products that respond to the marketplace. And that's good news for our customers and their customers. Steel offers high value to large and small consumers alike, outpacing competing materials in both cost and performance. And steel is completely recyclable, making it environmentally friendly. Steel, the most useful metal in the world. Versatile, corrosion-resistant, light, and strong. Today's steel is highly efficient, high-tech, and high quality. Today's steel is the backbone of America.